Learn structure activity relationship of quinolones. See, we have seen so many quinolones earlier, starting from nalidixic acid, then similar to that is enoxazine, norfloxacin, ciprofloxacin, ofloxacin, lomifloxacin, sparfloxacin, and gatifloxacin. Okay, after that moxifloxacin. Mechanism of action also we have learnt in the earlier video. Now the SAR, very important from this chapter, because maximum time this question has been asked. Now the alkyl substitution at 1. Okay, see, first position, fourth position, sixth position, seventh position, eighth position. Okay, we are talking about alkyl substitution at 1. It is very important for antibacterial activity. Lower alkyl substitution, greater will be the potency, and aryl substituent here, aryl substituent will give the consistent activity. Ethyl, fluoroethyl, methyl amino, methoxy, cyclopropyl substitutions at 1 will give the optimal activity. Now talking about second position. Substitution at second position reduces the activity. Next, pyridone. Pyridone system must be annulated with an aromatic ring. Okay, must be annulated with an aromatic ring. 1,4-dihydro 4-oxo pyridine 3-carboxylic acid is very much essential for the activity. So this particular group is this ring. These substituents are very much responsible for the activity. 4-oxo group is must. It is compulsory for activity because it only gives the binding with DNA gyrase. What is DNA gyrase? That is the enzyme here. Okay, these quinolones inhibit this enzyme so that this further DNA synthesis doesn't happen. So for this inhibition to happen, this 4-oxo is essential. At 2, 5, 6 and 8. देखो अभी 2, 5, 6 and 8. Consistent retention of antibacterial activity after replacing N instead of C. At these positions, if instead of carbon nitrogen is coming, then consistent retention of antibacterial activity has been observed. At sixth position, see, this sixth position is also very important. At sixth position, if fluorine is present, it increases cell permeation. Fluorine present at sixth position will increase the DNA gyrase complex binding also. Fluorine present at sixth position will increase the antibacterial activity also. Because of all these advantages of presence of fluorine at sixth position, now whatever recently synthesized quinolones are there, they all carry fluorine at sixth position because of all these advantages. Now next, at sixth position, even chlorine can be substituted. That also gives the active compound. Let us talk about third position. Third position, where currently this carboxylic acid group is present. At 3, reduction in activity if COOH is replaced by sulfonic acid, acetic acid, hydroxyaminic acid, sulfonamides and phosphoric acid. So this COOH is very much essential. This though we have seen here also. This 1,4-dihydro 4-oxopyridine, ये भी, this double bond. Okay, so everything is essential for the activity. So this COOH cannot be replaced by any other acid. Now at fifth position, see this fifth position, chlorine amino group, if it is present there, they will increase the activity, increase the absorption, increase the distribution, and phototoxicity can be reduced. Double bond between C2 and C3, this double bond. Okay, its reduction will eliminate the activity. So this double bond has to be there. Now at fifth position, if NH2 is there, at 5th position, if NH2 is there, sparfloxacin, we call that compound as sparfloxacin at 5th or 8th position. If OCH3 is there, okay, 5th or 8th, we are talking about 5 or 8 position. If OCH3 is there, gatifloxacin is formed. Okay, let us see their structures, gatifloxacin and sparfloxacin. Okay, this is sparfloxacin. You can see NH2 here for sparfloxacin. Gatifloxacin, OCH3 is here. So this is 5, 6, 7, 8. At 5th position, NH2 for sparfloxacin, and at 8th position, OCH3 for gatifloxacin. Okay, so they both, these substitutions, why these substitutions have been done? Because it reduces the phototoxicity. Okay, at 8th position, if halogen is present here, if halogen is present, we call that compound as lomifloxacin, which increases the phototoxicity. Okay, so phototoxicity increase हुआ ना by substitution at 8th position. See lomifloxacin, where is lomifloxacin? Here. Okay, this. Okay, phototoxicity increased. Okay, at 7th position, now let us talk about the 7th position. Where is the 7th position? This, where this piperazine ring is present. Okay, so at 7th position, if it is piperazine or N-methyl piperazine or pyrrolidine, the active compound can be obtained, which increases the anti-pseudomonal activity. But this can also increase the CNS side effect, which is due to increased affinity to GABA receptors. To overcome this, addition of methyl ethyl to piperazine ring can be done. So that will give us ofloxacin, sparfloxacin, or bulky substituent can be added at N1, which is the N1 here. Bulky substitution can be added to overcome this side effect. So if cyclopropyl we add at N1 here, that will give us ciprofloxacin. At 3rd and 4th position, see 3rd position पे this COOH is there, 4th पे carbonyl group double bond O. This is necessary for binding of quinolones to DNA gyrase. We have already seen this. Replacement of C8 by N. Here, instead of this carbon, if N is there, what will happen? That will give us naphthyridine ring, which is nothing but enoxacin. This increases the bioavailability of the compound. Now at 8th carbon, if there is second fluorine, so difluoro, we have seen earlier the examples of difluorinated compounds. See difluorinated, here also fluorine, here also fluorine, and that way. So at second carbon, if fluorine is, at 8th carbon, if second fluorine group comes, that will increase the activity, but it will increase phototoxicity also. And compounds with ring fusion at 1 at, for example, ofloxacin at 5, 6, 7 and 7, 8 will give us the active compound. So what is this ring fusion? Ofloxacin structure, let us see. See this ofloxacin ring fusion. Okay, so that also gives us the active compound. So that was all about the structure activity relationship of quinolones.